So hi everybody and welcome back to C++ tutorials for absolute beginners. This is video 320 and in this video we continue with our exercise, and like all time you should read the question, pause the video, answer as good as you can and then compare your answer with my answer or better with online resources and good C++ books. But before we go on, I have to note a very big mistake which I made in my last video, and I hope you realize that. And the big mistake is I called every value category an R value, and that is wrong because it is a PR value. And you could say, wait a minute, a PR value is also an R value, so it's not that wrong, but it is really wrong because an R value contains also an X value, and all these examples what I gave you, the number 13, 14 and 15 are definitely not X values. So you have to write PR value as the value category and not like I did accidentally wrote them R values. I hope you made it better than me. If not, don't worry, you see I made the wrong mistake. So let's continue now with the exercise from today, and we stopped here at number 16 and let's read it fast together. So what we have here, some operators and expressions, and what are those called? Try to find the technical term, and again value category, and make a code example. And like all time, I don't pause here the video, you should pause it. I jump straight to the answers, and here's the answer. First of all, these are called built-in arithmetic expressions, and then the value category is PR value, not an R value like I told you in my last video all time. And why are, by the way, why are this again PR values? Again, these are this expression which you see here have two operands, right? And then there is an operator, which means here we will the compiler will make all-time a calculation, and this calculation at this point, so it takes this operand, do something with the second operand, and the result is a temporary value, and this temporary value at this point is not bound to anything, for example not bound to a name or a storage, so which means at this point it is a PR value, and we learned PR value means it is not saved anywhere right now, and it is not saved anywhere at this point. So that's very easy to see that these are these expressions, this operator expression, most of them are PR values. So with that said, let's go to the code examples, and I made here very bad code examples. Why bad? Because never make something like this. When you see an A, B, C in coding means this nothing, but when you see it, then you can do something. You read it and then you can delete it, because that's why they are made. And in my case, exactly that's okay, because I show you this one and later I don't never use it again. So here I declare three variables, A, B, C, with default values. A is 5, B is 2 and C. And then I think I skip A plus B because plus is very simple, everybody knows. But this modulus sign here, I don't think everybody knows it. Modulus means just I'm interested in the remainder. Remainder means something like so. We have here C. Let's make my example. I want to assign C the remainder of A modulus B. Sorry. So what modulus means is you are doing something like that. You first of all you replace AB with the numbers 5 modulus 2, and this modulus here is nothing else a division, similar to a division, similar, not nothing, similar to a division what you learned in the primary school probably, because in the primary school you learned something like that. So you learned not 5 divided by 2 is 2.5, instead you learned probably something 5 divided 2 is 2 and the remainder is 1, because in the primary school you don't learn dot number, I think there's commas and so on, decimals and so. Okay, and exactly that is modulus. So they are using in C++ the modulus what you learned in primary school. And important here is they are interested most time in this reminder, because the reminder can give many informations. I give you a brief example. For example, if you want to find every odd number or even number, then you just can take any number, a, can be anything. In this case, it's 5. And then you make a modulus, which means just divide by 2. And if this one here, because I'm not interested in the result here, I'm interested in the remainder, this remainder will be 0 or will be 1. If it's 0, I know doesn't matter what a was, it was even. And if it's not 0, then I know doesn't matter what a was, it is an odd number, and you can use that information then to program on. So that is just a little example. We don't go too deep in this one, but we continue now with the next example. This is and here. Again, this and we know, but the problem is we know many use cases of them, and you should not confusing by them. For example, we know this could be an address of operator, or this could be, or there is another one with 2 double ands, this other one. I hope don't confuse it with that one. So what is this one? This one is a bitwise operator, and that's not so commonly used. Bitwise means just, again, let's go to my example here. The bitwise here is this example. Again, I want assign C, the A, this is again my A with bitwise B. The problem is, what means bitwise? Bitwise means, first of all, you take again the numbers. So, okay, A is 5. I write it the and I want bitwise it with 2. So bitwise says, I want to compare these 2 numbers, but not like the comparison operator which we learned. For example, this one, this equal here is also a comparison operator, but this one is a bitwise comparison operator, and with a special functionality. First of all, you convert these decimal numbers in bits, like so. The problem in this representation here is, for humans like us, not very readable, so we are converting it in this form. So you can see this 5, it's in bits like that, but you say, wait a minute, where are coming this all the zeros here? This is just to represent it in 1 byte, because 1 byte has 8 bits. You can count it. These are 8 digits. This is 1 byte, and you start from right to left. Okay, I start from here, right to left. This 101, I start 101, and all the other things are 0 because it's not used. The 1 means you do something, 0 means you do not something. And this 1 here in this bit is representing the 2. We start from right, the 2 power, and start with 0. So here, the 2 power with 0, when it means 1, yes, make this calculation. So it would be 1. Okay, we have here a 1. Then the 0 means 2 power of 1, but 0 means don't make this calculation, skip this. So I would get here 2 normally, but 0 says no, don't use it. Okay, I don't use it. I have still the 1 here, but I have not used this one here. And 1 means here, yes, 2 to the power of 2, use this one again. Okay, this one, when I use this one, becomes 4. So let's make here, I write it here just so, oops, not here. So we have used it, when I can write it. So the first one was 1 plus the second one we don't use, 0 plus the fourth one we used. So again, from right to left, right? That's what I did here. And the answer is indeed this one is our 5. And so I will not go on now with that because that can take too much time. So you have now the idea. So now I have this representation, and now I want to compare it. That was just converted, the 5 in bits, and now I want to compare it. Now I convert this 2 as well in bits. This is the representation of 2. And now this 2, I compare it. This is my result here. So let's make this clear. This one is the comparison result. And I get 0. Why I get 0? Because the bitwise AND means both digits here must be 1. Then I give you a 1. And if not, I give you a 0. And if it's a 1, you can calculate it like this, what I showed you here again. But the problem is here, when I compare 1 with 0, oh, 0, because both must be 1. It's not, so I give you a 0. 1 0, okay, 0. 1 0, okay, 0, and they are anyway 0 0 0 zeros, because they both must be 1. I give you, so I give you all zeros. The outcome is C. You can see my when I convert it back, it's 0. How I convert it back? Because we have never ones here, and no ones means 0. When we use here our calculation, we start from 0. Don't use that, 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 means it's just 0. All right, that was very short. This is much more complicated when you go really into this one, but I hope that's okay for now. We are more interested in understanding a little bit this kind of stuff. That you important is here, don't get confused with the address of operator and other other comparison operator. We will see it in a moment. So here the same thing again. This is again a bit shift left. So again, similar to this one again, but this time we have here, we take C, we have A, we have B, and now I want shift all this. I take this. I take the A, and the B is telling me how many lines I go to the left. I shift all the bits to the left. Important here, this shift means in bits. So you have to convert it this one. So A was our 5, you can see. I wrote it here down. And now what happens here is this B is telling this A how many parts you should go to the left. Let's make here the example. So you can see A is this one, B says 2. You should go 2 times to the left. In the bits it's very easy, because you know what the compiler is doing, it's just pushing there. You can see, okay, it starts with 1 0 1. So when I push this here, I write 0 0 here in front, and then I write just the number left. So in bits it's very easy. You write here 0 0 because I pushed it 2 wide, and then you write just the number which it was. Well, that was 1 0 and 1. And the other zeros again, it's just for 1 byte presentation if you have that. In my case, yes, you fill it up, and this one is our result. So again, I don't go too much deep into it, but yeah, you know this. And this is in bits, but there is something else in without bits, and the easy way is just you are calculating it with the power. You multiplying with the second power. Let me show you this one here. So the C, you can also write here A multiplied by the 2 power. Oops, not so. 2 power of B. The 2 power of P is 2. So let's make 2. This is the thing what you do. Oops, not so. Sorry for that. So this is what you do as a programmer instead of using shifting the bits here. This is the same outcome, because when you do this one, we get 20, and this result here is 20. And there is also the other way around, and you divide this here later by the 2 power of whatever B is. Here this 2 is just B here, right? When B would be 3, then you write here the 3. Depends on that B. Oh, okay. I hope, yeah, I don't go too much into this one. It's too complicated right now. We are not interested in too much that, but only, again, very important. Here, I forgot to mention this one. Don't get confused with std cout, what we all time use with this one here. Remember, we are using this all time here as well. This one here is not the same like this one, what I use here. Why not? They look similar, but this one here is, we already learned it in overloaded operator, which means this operator exists, and now in this case, it's overloaded with a special function to print out text to the console, right? So don't get confused with that. I think that's okay. And I think that's okay for this one. So important things we are done, I think. All right, let's continue with the thing here. So number 17. Again, read the question. Here we have again operators, expressions. And then it says here, what are those? Code again, value categories, and make code example again. So I jump to the answer. You pause the video and try it. So the answer here is 7. Also, these are called built-in logical expressions. You can see the difference. That was arithmetic expressions. And here are logical expressions. Logical, we already know them. I think we have already made this logical expression here, right? This AND. And when we have something like that, we use most time Boolean. So first of all, what are value categories? These are PR values. Again, why PR values? Because we take an operand, we take a second operand, and we are doing something, and we are not binding it to anything. Right now, at this point, it is just a result which is not saved anywhere, and that's why we have a PR value. And then here is a code example. Again, my super bad example. Don't make this. Make a better one, I hope. So again, I take it from top. Here I just have my standard variables again. And now here I create a bool variable. And then I say, okay, oh, this one looks already a little bit too complicated. But here I take 8 and b. Careful when you see 8 and b. This a and b can be an expression itself too. What I mean with an expression, you can see here, this is my a. Actually, this one is my a with this one. And my b is this one. And yeah, and this double ampersand is a logical expression. What means here logical in this case? So you can see here this ampersand again. Don't confuse with the bit one. This is logical. Logical means both sides is a Boolean expression. You can say Boolean expression that the left side, this A must be true and B must be true. Then I give you a return value of true, which means if one of this is not true, so if 8 is not true or B is not true, I will definitely give you a false. All right. And here what I want to point out at this example is one more thing. The thing what I want pointed out is first, this representation looks good. Many beginners like it, but programmers don't like it. Why not? Because this looks very simple, clear, and straightforward. But programmers like more this kind of stuff, which absolute beginners don't like. Let me show you what beginners hate. When they see it, they say, what the fuck? But to be honest, programmers like this more. And the question is why? Why does programmers like this? And the worst thing is this one, we are using A and B. So think about it, we are using now long names that would look really crazy. But programmers like this representation more. And beginners, when they see it, they say, oh my God, I'm lost. So the question is why? And the answer is very simple. This one here is straightforward. Everything is defined because we talked about this operator precedence, right? Some operator have faster, you have to calculate faster. For example, you know this one, right? When we have here 5 plus 6 multiplied by 7, you learned in school, oh, when I have this one, I have to calculate this first and then add 2, because if you are adding this one first and then multiplying, you have a wrong number. And this is similar in programming in many cases as well, but programmers hate to think about and watch every symbol here which has a higher precedence, which means which comes first. So they avoid this by just setting this round brackets, because then it's clear. Here you can say, okay, this one will be calculated before this ampersand. This one will be calculated before I use this one. This one here will calculate it before I don't know why I have this one here actually. I think I overcomplicated it a little bit. Sorry about that. This one here will be used, also this one here will be used in the last. So this one is very clear. Beginners don't like it, but programmers make it to make it absolute clear, and you should do this as well. So that is that, and let's go here to, that was the AND. This AND means both sides must be true. If one side is wrong, that will be wrong. Let's test our little example here. What is the outcome here? Can you see it in my case? So here 8 less b, 5 is less than 2. Is this true? No, it's false. But this was this here. Now you see why I have this round brackets. That was just this one. Now I have calculate this brackets. That was false. This here is this one here. That is, by the way, this example is a negation. Negation means to turn the value, turn the value, which means if you have here true, it becomes false. If you have here false, it becomes true. Negated. The right term is negated. Okay, so which means we have here was false, it becomes true. So that is my second calculation. So this side is true. And now I have here my AND, and now I have to calculate this first here. It says A is greater than C. Yes, it's true. So true here, and we have a result of true, and this must be a bool variable because we are comparing here a bool value, right? That's why I have here a bool variable. Okay, the value is here true. Again, you see this yeah, these operators can get really nasty when you have too many, but yeah, this is a topic for another time. So here and here we have this other operator as well. This is this OR operator, which is what it means OR. OR means just when one side is true, the whole expression will be true, which means when I replace this with a OR, oops, when I can make it right, where is that? Here. This one, which means I don't need this one. Let's skip this one for a moment. Here, this one is false now, right? Because 5 is not, this one is false, but this one is true. And this one becomes true. And if I put back this one in now without the ampersand here, this one becomes false because one is already false, this one. Then doesn't matter what this one is, it becomes false. But again, I hope you get this a little bit, and later you will be better in this one. But here in this case, it's important that you understand when you see operators that you see, most time they are PR values. Again, why? Because they are calculated and they are not saved. So you can see I calculated here the outcome, it's true. At this point, it is a PR value, but when you bind it to a variable, the whole expression is no more PR value because I have here name now. After this point here, after this assignment, it's no more PR value. All right, let's go on to the next question. And the next question is our 18. And again, we have operators. But these operators we already know. I hope we have already talked much about them. So what are those called? Value category again, and make code examples. Again, pause the video and I jump into it now. Here I go a little bit faster. These are the built-in comparison operator. Yes, we did this here in top already. This equal sign, for example, and here we have this equal sign. Here is greater, equal, and here we have this less. They are straightforward. This greater equal is sometimes not clear sometimes, which means it can be equal or greater. Just so here, let's watch here and fast an example. Again, these are PR values. Again, same reason like before. You take here this operands and then you calculate it. As long as they are not saved to anything, bound to anything, there are values which are just calculated at this point and saved nowhere. That's why they are PR values. And here again we have my example like before, and here I have made a fast if statement. And when you see what kind of if is this, where are the round this curly braces, this is the short version of the if statement. See, you see this many times as well. Works only if you have one line, which means if you go here a little bit more down, that will not work. Keep this in mind. But here I take 8, again my value is 5, and then if it's greater than b is my 2, which means it is not greater, then I would make this one. But I mean, sorry, it's greater. 5 is greater definitely than 2. So if this is true, if it's true, it will jump into this line here, and it will set a to 3 because I divide this one. So, and let's go here, comparison. I think that was this example here on top. We don't need, and this greater equal, so you can make this one also here greater equal. If I make this one greater equal, is this changing anything? No, but I could say this becomes true. But if b would be, for example, 5, let's change here b also to 5, and let's go here fast back. This one would be false with this new value 5b, because 5 is not greater than 5. This is equal 5. Then it will not jump here. But if I have equal now, so both are accepted, so you can be greater or the same, then it will jump as well here. All right, that's it for this exercise. It was a lot. I hope you managed them, and don't worry if you have not managed it bitwise here. They are a little bit more complicated and need a separate video when you go into this one. But with that said, I stop here. Have a good time, and like old time, never give up and have fun. Bye.